Hi friends, very good morning. So today what we are going to discuss with the help of my channel, basics of electronics. Basics of electronics, okay, right? So what are the objectives we are going to focus today? Basic components of electricity, recognize the three electrical classification of material, compare and contrast AC versus DC, explain the concept of grounding, as well as Ohm's law, Watt's law, how we have to define current, voltage, resistance. Okay, fine. Now, what do you mean by electrons? So electron is the smallest amount of electrical charge having the quality called negative polarity. Electrons always have a negative polarity, as well as it looks like a smallest amount of electrical charge. So it is center of the atoms. Electrons are always center of the atoms. What is protons? So protons is a basic particle with a positive polarity. So electrons are a negative polarity, protons are a positive polarity. Okay, so protons are located in the nucleus atoms along with neutrons, particles which have a neutral polarity. See, here I'm showing one atomic structure of hydrogen as well as a helium. See how the electrons, see proton and electrons combination process will, which takes place. Just I'm showing. See, electrically, all material fall into one of three classifications: conductors, insulators, as well as semiconductors. So, electrically, all type of material fall into one of three classifications. What are the classifications? Conductors, insulators, semiconductors. So, conductors have only one valence electron. So, material in which in conductor, in material in which electrons can move freely from atom to atom. So if you have a conductors, electrons will move freely from one atom to another atom. That is the advantages of using conductors. Oh, all metals are a good conductor. Very real-time example. Real-time example for conductors, or all metals are a very good conductors. So next, the purpose of conductor is is to allow electrical current to flow with a minimum resistance. With the help of conductors, so the current flow will, which you see, current flow is moving to the circuits minimum level, minimum resistance level it used to maintain. That is the main thing we are always focusing on the conductor. So insulator, coming to the point, insulator have a 8 valence electron as well as the in insulator material which in which electrons are tended to stay put and do not flow easily from atom to atom are termed insulators. It never, so compared with conductors, insulator never really move from one atom to another atom. So it little bit it is somewhat complicated compared with conductors. So as well as insulator are used to prevent the flow of electricity. So with the help of insulator, so the safety precautions are very more so good, very good safety precautions if you have insulators. So insulating materials such as glass, rubber, plastic are also called dielectric. Meaning what that mean they can store charges. So the main purpose of here you one thing you must and should every one of you keep in mind. Insulator is a real-time application for insulator is, keep in mind every one of you friends, it's a protection. I mean safety purpose to prevent the flow of electricity. So to prevent the flow of electricity is a very most important real-time applications related to insulator. But compared with the conductors, insulators little bit have a drawbacks. So always we preferably we are going to use conductors. Next, dielectric materials are used in components like capacitor, which must store electric charges. Coming to the point, semiconductors. Semiconductors have a 4 valence electrons, as well as in semiconductor material, which are neither conductors nor insulators. The common semiconductor material are carbon, germanium, and silicon. These are all common material for semiconductor material. So it is mainly used. Semiconductor material used in a components like a transistor. So transistor is the best example for a semiconductor material. So compared with the conductors, insulators, semiconductor, conductors are very good, which used to carry current conduction. If you have a conductors, current conduction will happen very good. So that's what always for electronics engineer always we are preferring conductors. Um, Semiconductor is acted as a conductor as well as an insulator. It has 4 valence electrons. The best real-time example, transistor. Transistor is a very good real-time example for semiconductors. Then coming to the point, what do you mean by voltage? Voltage is nothing but a potential. It refers to the possibility of doing work. So it may be represent E, potential difference E. So even the symbol can be represented mathematically E. The practical unit of potential difference is volt. V. So specifically, I represented here V. Okay, 1 volt is measure of the amount of work required to move 1 coulomb of charge. So 1 volt, which is equal to 1 coulomb of charge, we may able to represent. So keep in mind, friends, see what is the unit of voltage? Volts. Well, so how we may able to represent voltage? E or either E or V. Okay. So what is the voltage? Potential refers to the possibility of doing work. So next, current. So what do you mean by current? When a charge is forced to move because of potential difference, current is produced in any circuit. So conductors. So coming to the point, conductor. Free electrons can be forced to move with a relative case since they require little work to be moved. That is a thing. Conductors are very important here. We are discussing, right? So current is charge in a motion. Simply, the more electron in motion, the greater the current. Next, the point which is going to discuss resistance. Resistance to opposition to the flow of current, termed as resistance. Of course, what is the unit of resistance? Ohm. So conductors have very little resistance. So insulator have a large amount of resistance, right? So that is the thing you want to know, that with the help of resistance. So resistance is very most important point in electronic fundamentals, right? Right, fine. So next, coming to the point, closed circuits. Already I discussed it in the previous video. What do you mean by circuits? It is a closed path. I mean combination of electronic components. So what do you mean by closed circuit here? The path of current flow. I mean, a circuit is defined as a path of current flow. Already I given here. So you can see in applications requiring the use of current, electrical components are arranged in the form of a circuit. Electrical components are arranged in the form of a circuit. That is nothing but a closed circuits. See here, I'm showing common electronic component symbols. See here, the first symbol is represented as a battery. Battery terminal consists of a positive terminal and a negative terminal, and the resistor looks like it looks like a speed breaker, ups, down. So if you have a resistor, a current flow in the circuits linearly will move on. As well as switch. This is a switch symbol. This is a diode symbol, anode and cathode. This is a light emitting diode symbol. Symbolic represent these are all symbolic representation of some electronic components. See how open circuits. So here I made it one open circuit. See here I made it one open circuit. I removed the resistance here. So open circuit means like that. In open circuit, current value always 0. So that here I represented I equal to 0, right? So here, how the electron, see, once you're going to apply the power supply to this so the device, so how electron flow will happen? Electron flow will happen. See, electron and hole, how the recombination process will take place. This is nothing but electron flow. See how electron conduction will happen in the circuits. So just for your understanding purpose, I'm showing electron flow in a simple circuits. So DC, direct current. So in circuits that are powered by a battery sources are termed direct current circuits. This is because the battery maintains the same polarity of output voltage. The plus and minus sides remains constant. Okay, the battery maintains the same polarity of output voltage. Circuit, see DC, which indicate means a direct current. I mean, powered by a battery sources are termed direct current. Okay, if you have a battery, if you give a power supply to these circuits, see that comes under direct current concept. Okay, see here is a waveform representation of DC voltage. DC voltage only we have only straight line. Coming to the point of characteristics of DC, characteristics, it is the flow of charge in just one direction. So it will it will flow only one direction. The fixed polarity of applied voltage, which are characteristics of DC circuits. Fixed polarity. So DC circuits, so DC circuits means so fixed polarity as well as the direction of the charge only one direction. So AC means expansion of AC, alternating current source. So periodically, it is going to periodically alternate and reverse the polarity. Either it may be a positive or a negative. Okay, so the very good real-time example is an audio signal. Audio signal is very good examples. Very good example for audio signal, right? The resulting current, therefore, the periodically reverse in the direction here. The power outlet in your AC, your home is a 60 cycle AC, meaning the voltage, polarity, and the current direction go through 60 cycles reverse per second. reversal per second. See, I'm showing this is nothing but a waveform representation of AC voltage. Waveform represent how we have to represent AC signal. So like this, you have to represent like this. Sinusoidal waveform is see here I'm represent peak to peak value, peak to peak voltage, peak to peak voltage I represented. Yes, okay, right. Next, complex form of voltage. So how the complex signal will be like that I'm showing. So next, the DC voltage and AC voltage comparison. This is DC voltage fixed polarity, AC voltage reverse polarity. As well as can be AC, DC voltage is steady and AC voltage is vary. We may be able to vary. So DC voltage can be able to measure easily. This AC voltage is also easy to amplify. This and all comparison between DC and AC. So coming to the point, so in many many circuits include both AC and DC voltages. Of course, this is compared to DC circuits usually simpler than AC circuits. DC circuits are usually simpler. Compared to AC circuit, DC circuit is a best thing. Very simple to design compared with the AC circuits. So best thing, DC circuit are easy to design. That is the thing. But both have advantages, no doubt at all. So only the thing is DC circuits have a simple design. So next, coming to the point, the impedance. Impedance is a resistance to current flow in a AC circuit, and its a symbol is, see, we are representing the symbol is Z. Impedance is also measured in ohms. So impedance also measured in ohms. Impedance is a resistance. Impedance is a resistance to current flow in a AC circuit. So mainly we are focusing in a AC circuit. So grounding connection. So in the wire, how we are going to define grounding? Here, in the wiring of practical circuits, one side of the voltage source is usually grounded for a safety. Why we go for the grounding? For the purpose of making safety connections. See here, I'm representing some of the grounding connections. See, this is we may able to represent like this. So when you're going to draw the circuit diagram, so you have to specify like this. These are all three symbols which indicate earth, ground, chassis. It will indicate a common symbol of ground in electric circuits. Ohm's law. So with the help of Ohm's law, we may be able to find current, voltage, as well as resistance also we may be able to find. Let's see here I given a equation. I is equal to E by R, E is equal to I into R, R is equal to E into I. Here E is a voltage, I is a current, R is a resistance. This is current is directly proportional to voltage for a constant resistance with the help of Ohm's law. How it is see that is a curvature representation. Like that, inversely proportional to resistance for a constant voltage. How it is? See, just I'm representing. This is for curvature representation for your understanding. So power. Coming to the point, power. The unit of electrical power is watt. Okay. So I mean, power is how much work is done over a time. Within a time, how much amount of work you've done is nothing but a power. So power is what is the unit of power? Watts. So power can be calculated in a different formula. P is equal to E into I. P is equal to I squared into R. P is equal to E squared by R. So here P is nothing but a power. E is nothing but a voltage. R is a resistance. This is a conversion factor for your understanding purpose. A mega, kilo, milli, micro. This and all symbol. Mega means M, kilo means K, milli means small letter M, micro means mu. So 10 to the power minus 6 micro, 10 to the power minus 3 milli, 10 to the power 3 kilo, 10 to the power 6 mega. This and all conversion factor for your understanding purpose. So thank you, friends. Thank you for watching this PPT presentation. Thank you. Thank you so much. If you like, kindly kindly subscribe my channel, Sandy Space Puppy. And if you have any queries, contact my mail ID, hsnglobal@gmail.com. Thank you, friends. Thanks for watching.